Hey guys, a very warm welcome to today's session. This is Amiraj and I welcome you to the second session of Carbon and its Compounds Class 10 CBSE Chemistry Chapter 4. And in today's session, we'll be understanding the concept of versatile nature of carbon, about some special allotropes which we have and some other important concepts. So let us get started and I welcome you to Carbon and its Compounds Versatile Nature of Carbon class. Right, so are you ready? In case you're ready, you have to hit the like button, you need to share the video among all your friends, and you need to subscribe to the channel. Okay, now first we're getting started with a do you know wala form, a do you know wala concept, a very interesting fact. See, the number of carbon compounds whose formulae are known to chemists. So what do you think, how many compounds, how many formulae are known to the scientists, the chemists? Any idea? You would be shocked. 3 million. Can you just imagine? Can you just count the zeros in this term, in this number 3 million? So many compounds are known to chemists. That's a very big thing. Yes, this outnumbers by a large margin of compounds formed by all other elements put together. That is why for carbon we have organic chemistry, because it forms so many compounds you cannot imagine. Right, so what helps carbon do this? How does carbon actually form so many bonds with different elements, with different atoms, which outnumbers the other elements, the bonds formed by other elements, the bonds formed by the ionic compound? Yes. Now, unique nature of carbon. Carbon has something unique, something peculiar about it, which no other element has. So what is that, guys? Number one is property of catenation. Catenation means self-linking property. So what happens, guys, that carbon forms bonds with itself. Like you can say in this way, carbon reacts with itself to form a bond. So it can make different chains, different branches, different rings. What are chains, branches, and rings? It means making the compound in such a way that they have different structure. Either you can arrange it in a chain form, chain, long chain, or a branch form, or a ring form. Okay, that is catenation. That is a self-linking property of carbon. And the valency of carbon. What is the second important property? That is the valency. Basically, we call it as the tetravalency. What is tetra? Tetra is 4. Okay, here tetra is 4 valency. It means its valency is 4. That is very unique. Clear? Now, first we're talking about the valency of carbon, that the tetravalency or 4, that is 4, is capable of forming bonds with 4 other atoms, because you know it will form covalent bond. I taught you. In case you have any queries, please find the link in the description box of the previous video. Here, so see guys, concentrate over here that it can form bonds with 4 other atoms, which is a very big thing, which other elements cannot do. So this becomes a special property, yes or no? Because see, it wants that 4 of the atoms of other elements should share electrons, so that carbon will share with them, they will share with them, so carbon's octet will be completed to 8, right? So size of the carbon makes the bond stronger. Reason for stability of compound. How carbon compounds are stable? Because of size of the carbon. It is small, right? Small in size. That is why it makes the bond stronger and stable. Correct, everyone? And tetravalency, as I told you, capable of forming 4 bonds. Like we talked we talked about methane, right? Carbon shares its electrons with 4 atoms of hydrogen, individual hydrogen atoms, and those 4 hydrogen atoms share the electrons with carbon. In this way, their octet and duplet gets completed. Now talking about catenation. What is catenation? Property of an atom to bond or to combine with itself. This is the linear chain, this is the branched, and this is the closed. So in this way, any kind of chain or branch can be formed by carbon. That is the special property. Now talking about bonding in carbon, carbon forms bond by sharing of electrons, that is known as covalent bond, and one carbon atom forms 4 bonds. Right, as I told you in the previous session, these are the points of previous session and very important. Covalent bonding, when we are talking about sharing of electrons, because carbon bonds 4 atoms, 4 electrons, right, from different atoms. So 4 bonds. In this way, 4 bonds are made. And talking about the types of bonds, I told you that can be the single bond, the double bond, or the triple bond, and indicated by this: single bond, single dash, double bond, double dash, triple bond, triple dash. Correct? Now, methane, I talked about methane in the previous session also, that which is carbon and hydrogen combination. And that combination is very important for understanding the hydrocarbons, for understanding the homologous series and the alkanes, alkenes, alkynes. In the next session, I'll be talking about all the three: alkanes, alkynes, and alkenes. Okay. Carbon attains stability by octet and hydrogen by duplet configuration, as you know. So let us just recall that. Suppose this is my wait a second, let me change the, just a second. Let me change the pen. Okay. Suppose this is carbon, right? It can share its four. Let me make the electron dot structure instead of the structure. That will be easier for you to understand. Okay. So how many electrons does carbon have, guys? 1, 2, 3, and 4. 4 electrons with carbon. Now talking about hydrogen. Now there will be 4 hydrogens. Hydrogen number 1, number 2, number 3, and number 4. And you know each hydrogen has 1 electron. So what it will do, first all the hydrogens will complete their octet. See, talking about this hydrogen has completed its octet. This also 1, 2, duplet, sorry, duplet, not octet. 1, 2, duplet completed. 1, 2, duplet completed. So carbon has shared the electrons with hydrogen so that each of its duplet will be completed. And now talking about carbon, so as you can see over here, is this color visible? Yes. So 1, 2, 3, 4, 5, 6, 7, 8. So octet completed. Octet completed. 1, 2, 3, 4, 5, 6, 7, 8. 4 its own electrons and 4 electrons from 4 hydrogen atoms. Okay. This vital force theory will be covered in the next session. Okay, if you want to know. Okay, we are not focusing over here. Now let's move on. Now, why carbon forms strong and stable bonds? This can be a subjective question, so please pay attention. One reason for the formation of strong bonds by carbon is its small size, as I told you, so that it can get attracted easily with other atoms, right? This enables the nucleus to hold on to the shared pairs of electrons strongly because of its small size. Why? Because the nucleus can hold the shared pairs strongly, okay, without any breakage, without any problem. Now, formation of single bond and triple bond, as you're able to see, methane single bond, then triple bond of nitrogen with itself, right? So all these constitute for the properties of carbon. Okay, now have you ever heard about it? Just tell me. Presence of only a single bond. See, now we are talking about single bond, double bond, and triple bond. Single bond meaning where only one pair of shared electron is there, right? Double bond where 2 pairs of electrons are shared, and triple bond where 3 pairs of electrons are shared. So remember, if it is a single bond, then the compounds formed by single bonds, for example methane, for example ethane, right? Yeah, so what happens that they are termed as saturated hydrocompounds, okay, or you can say saturated hydrocarbons, saturated compounds. Whereas if there is a presence of double or triple bond, okay, due to MC, double bond will be indicated by these 2 arrows, then they will be termed as unsaturated compounds. Now I'm going to tell you a very important thing that you need to write it down. 1 minute, I'm cancelling this. Before that, please write it down. Open your registers of chemistry and write it down. If there is a single bond, then the group of compounds formed by single bond will be termed as alkanes. Alright, alkanes. Correct? If we have the double bond, as in case of, I will come to that in the nomenclature also, how to name. Right now I wouldn't reveal the names. If there is a double bond, then it is termed as, the group is termed as alkenes. Correct? And if you have a triple bond, then it will be termed as alkynes. So alkanes alkenes and alkynes. This is something which you should remember. So by this we conclude that alkenes are saturated compounds, whereas alkenes and alkynes are unsaturated. Now talking about allotropes. Okay, what is allotrope? Meaning allotropes of carbon are the you can say the different forms of carbon, right? Although they are totally different from carbon, but its forms, different forms. Physically they are different. Okay, physically they are different, but chemically they are the same. Chemical composition includes carbon atoms. Carbon is a nonmetal that can exist in different forms. Each form is called as the allotrope. And the most common and the most important allotropes are graphite, Buckminster fullerene, and diamond. I talked about it in the previous session, also related to covalent bond. So please revise that. Now, diamond, can you just imagine diamond and graphite? They are having the same chemical composition of carbon. Isn't it strange? See, diamond is an allotrope of carbon and it is the hardest natural substance known, and it has a very high melting and boiling point. So first is diamond, you should know about it. It is the hardest substance known. This is an MCQ also at the same time. Okay, and it has a very high melting and boiling point. Diamond has a rigid structure. It means if it has a rigid structure, it doesn't have free electrons because it is compact. Okay, it's packed completely, so there is no space for the electrons to move. So if guys there is no space for the electrons to move, it means it will be a poor conductor of electricity. Mark my words. What did I say? If in case it has a rigid and compact structure, then free electrons won't be moving, and because of which it will become what? An insulator, a poor conductor. Now, what are the properties in diamond? Strong three-dimensional networks are formed due to the presence of covalent bonds, hard in nature, and high melting and boiling point. Since molecules are closely packed, they have high density. Density is high, remember that. Okay, since there is no free carbon atom, the diamond does not conduct electricity. Whereas the one of the allotrope of carbon is conducting electricity, that is graphite, the other one is not conducting. So what is special about graphite, because of which it conducts electricity? An allotrope of carbon is a conductor of electricity. Why? Because of free electrons. Same concept is there. Okay, graphite is a good conductor. Why? See, it has a layered structure, right? Because of that layer structure, there are some free electrons which move, and as they move, they conduct electricity. They result in charges. You all must have read about physics. It's soft in nature. Just now we read the properties of diamond. It is the hardest substance known, and now on the contrary we get to know it is soft in nature. If you have seen your pencil lead, okay, then you all must have observed. If you can see this, just a second, let me show you the pencil. See, if I want to break it, I can easily do. Correct. See, if I'm gonna break it, then it can easily be broken. Why? Because it is soft. Yes. Why? Again, the question comes because of the large gap between the molecules. It is not tightly packed. Because of that gap, they have low density. They are not dense, right? Because of the presence of free carbon atom in graphite, they can conduct electricity, and it has a layered structure, not a compact structure. Remember that. Okay, and fullerene, that is Buckminster fullerene. The first one to be identified was C60, which has carbon atoms arranged in the shape of a football. So how many of you are lovers of football? Raise your hands. How many of you like to play football? Ki chalo, football khelenge, right? If you couldn't see it, just look at it once more. Actually, I think I did not show you this one. This slide, just have a look at it. I discussed about the conduction of electricity and layered structure. Okay? And sorry for that. This Buckminster fullerene is in the shape of football. Sorry for that, for wrong pronunciation. Okay, this looked like the geodesic dome design. See, it's like a dome, right? By our architect Buckminster Fuller, the molecule was named fullerene. Clear? Because of the architect who discovered it. And now homework question for you, that is, what are the two properties of carbon which lead to a huge number of compounds we see around us? And thank you so much. Do like, share, and subscribe, and do comment the homework answer in the comment section. Until then, we will meet. Bye bye.